In this video, we're going to look at limiting reactants, and we're just going to start with definitions that you need to know. So for limiting reactant, what we're talking about is the reagent that limits the amount of product that can be produced. That is, what is the least amount of stuff you have as a reactant? A theoretical yield is the amount of product that can ideally be made using your limiting reactant. If your reaction went to 100%, that is what you would get. Your actual yield is what you actually measure of your product. How much product do you ever get? And note that you will almost never go to 100% completion in any reaction. And your percent yield is your actual yield divided by theoretical times 100. Or the way I remember this is what you got divided by what you should have got multiplied by 100. Alright. So let's go back to this octane burning reaction we talked about in the last video. And we're going to figure out what is our limiting reactant. So let's say we're doing this reaction in a lab. And we have 6 moles of octane and 100 moles of O2. And the question is, with these starting reagent amounts, how many moles of CO2 can we make? So let's take a look at how we do this. So we have enough C8H12 or octane to make. So we start with 6 moles of octane. And we have a conversion factor. For every 2 moles of octane, we make 16 moles of CO2. Or 48 moles of CO2 once we do the math. For oxygen, we have enough O2 to make. Well, we start out with 100 moles of oxygen. And our conversion factor is for every 25 moles of oxygen, we make 16 moles of carbon dioxide. So, with this starting amount of oxygen, we could make 64 moles of CO2. Which means that octane is our limiting reagent. So, if we start with 6 moles of C8H12 and 100 moles of O2, we're going to use up all 6 moles of C8H12, and we're going to have leftover of O2. And the maximum amount of product we can make is 48 moles. Because once we get the 48 moles of carbon dioxide, all of our octane has been used up. Yep, so C8H12 is the limiting reagent. So let's test your understanding of this. I have a new equation for you given here. And I already give you the molecular weight of these elements, so you don't need to look them up in a periodic table. And I've already balanced the reaction for you. But let's say I have 18.3 grams of C2H5Cl, and I react that with 37.3 grams of O2. What is my theoretical yield in grams of Cl2? And what is the percent yield if 9.3 grams of CO2 was produced from the above reaction? So take a minute, pause the video, try to come up with an answer, and come back to the video when you have one. Alright, let's see how we solve this. Again, this is just dimensional analysis. And we're going to start with C2H5Cl. So I say in the problem we have 18.3 grams of this reagent. Well, in our stoichiometry, we use moles, so we want to get this to moles. And the molecular weight of C2H5Cl is 64.51 grams per 1 mole. And from our stoichiometry, we see that 4 moles of C2H5Cl will make 2 moles of Cl2. Now, the question asks, how many grams of CO2 will we make? So I'm going to make that extra step where we say 1 mole of CO2 is 70.906 grams of CO2. Again, just molecular weights. We can calculate that from up here. And we get from C2H5Cl, we can make 10.1 grams of CO2. But we have to do it for the other reagent, O2. So we have 37.3 grams of O2. Again, we don't want to work in grams, we want to work in moles. Now there's 16 grams of O2 per 1 mole of O2. So that's actually supposed to say O2 up there. We have 13 moles of O2, stoichiometry, makes 2 moles of Cl2. and 1 mole of CO2 is 70.906 grams of CO2. Again, our units in grams CO2. We're good to multiply and divide. And we get, with this amount of O2, we can make 25.4 grams of CO2. Therefore, C2H5Cl is your limiting reagent. This reagent makes less CO2, so it is limiting. Now we said that our percentage that we actually got in the lab was 9.3 grams. So our limiting reagent, our theoretical yield is what we got, 9.3 grams, divided by what we should have got, 10.1 grams, multiplied by 100 to give us 92.1%. That's our percent yield. And that's it for this video. And I'll see you in the next.